Let's continue the rest of the operators here. Next one is bitwise operators. Bitwise operators perform the operations on the given input bit by bit. But the condition is the operand should be integers, and they treat the integers as the sequence of bits, zeros and ones. Here we are having four types of bitwise operators: bitwise AND, bitwise OR, bitwise NOT, and bitwise XOR. Here we can use the symbols as shown in the table. Bitwise AND, the bit in the first operand is AND with the respective bit in the second operand, operand 1 and operand 2. If both the bits are 1, the output bit will be 1, otherwise the output bit will be 0. Here A is equal to 5, B is equal to 3. Let's check what is the value of A bitwise and B. And it's 1. How? The value of A, the binary stream, is 101. For B, 011. And it is going to check the AND operation between bits, the corresponding bits of A and B. So it's going to take 1 and 1, it is 1, 1, 0 and 1, it is 0, and 1 and 0, it is 0. And so the output value is 1. Now let's take a bitwise operator OR. The bit in the first operand is ORed with the respective bit in the second operand, and it will proceed till the end. And the syntax is operand 1, pipeline symbol operand 2. And if any one of the bit is 1, the output will be 1. Otherwise, any one of the bit is 0, the output is going to be 0. Let's take the same example. A is equal to 5, B is equal to 3. Print A or B. And the result is 7. How? The binary bit stream for A value 5 is 101 and for B is 011. And let's do the OR operation. 1 or 1, the result is 1. 0 or 1, the result is 1. 1 or 0, the result is 1. So 111, which is equivalent to 7 in decimal. Let's take bitwise operator NOT, and it's a unary operator. So the syntax is operator followed by operand. It performs logical negation on every bit of the given operand. So it produces the ones complement of the given operand. It means the zeros will be converted into 1 and ones will be converted into 0. And bitwise operator XOR, the bit in the first operand is XORed with the respective bit in the second operand. So the syntax is here. If one of the bit is 1, the output will be 1. If any one of the bit is 1 and the other is 0, it means that if both the inputs are different, then the output bit is 1. If both the bits are same, either 0 or 1, the output will be 0. So here A is equal to 5, B is equal to 3. Let's check what's the output of A bitwise XOR with B. It's 6. So here comes the table. The value of A is 101. The value of B is 011. Let's take the corresponding bits 1 and 1. Since both the bits are same, the output is 0. And 0 and 1, they are different, the output bit is 1. 1 and 0, the output is 1. So the resultant value is 6 in Python. The next type, membership operators. Here we have two membership operators which are represented with the help of keywords in, not in. If we want to check whether an element belongs to a sequence, then we can use the in keyword. And if we want to check whether the element is not a member in a sequence, then we can use the keyword not in. The syntax is element in is a keyword followed by the sequence in which we want to check the membership. Element not in sequence. That's the second thing. So these operators check for the membership of an element in a sequence, and in returns true if the element is found in the given sequence. It returns false otherwise. And in contrast, not in returns true if an element is not found in the given sequence and return false otherwise. So let's see membership operators while learning the sequences in Python. The next type, identity operators. We know that Python deals everything as an object. So identity operators will help us to check whether an object is same as another object. So we can check whether an object pointing to the same object, then it can be tested with the help of is keyword. And not pointing to the same object can be tested with the help of is not. The syntax here is operand 1 is operand 2. If both the operands are pointing to same object, it will return true. Otherwise, it will return false. Operand 1 is not operand 2. Here it is checking whether both the operands are not pointing to the same object. If so, it will return true. Otherwise, it will return false. So identity operators compare the memory locations of the given two operands, operand 1 and operand 2. And this is the keyword which represents the identity operator, and it returns true if both the operands are pointing to the same object in the memory. It will return false otherwise. If not, returns true if both the operands are pointing to the same object in memory. Otherwise, it will return false. The last type, shift operator. We are having two shift operators in Python, shift left and shift right, represented by the symbol 2 less than symbol and 2 greater than symbol. So the syntax here is operand followed by the operators followed by the num, the integer, number of times we wish to shift either left or right. So the operand bits are now shifted either left or right depending on the operator we are giving. And how many number of bits should be shifted either left or right will be denoted by the num, okay, the constant. For example, if we are having a is equal to 0001 1101, if we are shifting a left by 1 bit, then the output is going to be 00111010. It means that the leftmost bit will be dropped, that 0 will be dropped, and all the bits will be shifted one step towards left, and finally on the rightmost end another 0 will be added. Let's see some more examples. So a is equal to 00011101. Let's do left shift on a 4 times. So a is going to be the result 11010000. How? In the first step, the first bit is going to be, first leftmost 0 is going to be shifted, and on the right side, rightmost side, 10 will be added in order to make it as 1 byte. And in the second shift, another 0 will be moved off. So the output is going to be, the resultant value is going to be 01110110. One more 0 is added on the rightmost side. And again, during the third shift, the 0 is gone. So we are having the bit stream as 111010 and newly added 0. And during the fourth time, the leftmost 1 would be dropped off, and the result is 1101 and 0000. So that's the result after shifting a 4 times left. And let's do the same for right side shifting. So a is equal to 00011101. So during the first shift, the rightmost 1 would be dropped, and we'll be having a newly added 0 on the leftmost side. And during the second shift, the rightmost 0 would be dropped off, and all the bits are shifted towards right by a padded 0 on the leftmost side. And here, a 1 on rightmost bit will be gone, and newly padded 0 on the leftmost side. And finally, the one more 1 is dropped off on the rightmost side, and we are having 00000001 as output. So hope you understood the types of operators in Python, and kindly practice the same in the laboratory session. Thank you. Happy learning.